computer has several important parts, and if even one of them fails, it can negatively affect how the other components function. The first and most important part is the motherboard. As the name suggests, it's the mother of the computer. Without it, none of the components can communicate with each other. It's the central platform that holds all the hardware together and allows them to communicate as a system. If you look closely at a motherboard, you'll notice tiny lines running all over it. These are called circuits. They connect every component and carry electrical signals, essentially sending data and messages between different parts of the computer. Almost every electronic device you see has some form of a motherboard. However, not all motherboards are the same. Depending on your need, you can choose the one that works best for you. They come in different sizes and form factors, such as a mini ITX, micro ATX, ATX, and eATX. Each size offers a different number of slots and expansion options. The larger the motherboard, the more hardware you can add, and of course, the more you have to check your wallet. Next is the CPU. CPU stands for Central Processing Unit. It's one of the motherboard's children and is considered the brain of the computer. Just like our brain, the CPU receives data, processes it, makes decisions, and then executes instructions. As we discussed before, CPUs are measured in hertz. Nowadays, they operate in gigahertz. The higher the hertz, the more clock cycles the CPU can perform per second. However, gigahertz does not mean the number of tasks a CPU can handle. It simply represents how fast the CPU can go back and forth. Some tasks require more clock cycles than others, and some requires less. CPU performance depends on several factors, not just clock speed. These include clock speed, gigahertz or gigahertz, IPC, which stands for instructions per cycle, number of cores, and architecture. So having a high-end CPU with high hertz alone doesn't automatically guarantee great performance. All of these factors work together. There are several CPU manufacturers such as AMD, Intel, and Qualcomm, with AMD and Intel being the most common in desktop and laptop computers. When buying a motherboard, it's very important to check which CPU brand and socket it supports. Motherboards are not universal. Each CPU uses a specific socket type. For example, AMD and Intel CPUs have different physical designs, so they are not interchangeable. Here's the difference between the AMD and the Intel CPUs. Next is RAM. RAM stands for Random Access Memory. It's another one of the motherboard's children and acts as the short-term memory of the computer. RAM holds data that the CPU is actively working on while the computer is powered on. As soon as the computer shuts down, that data is lost. There are different types of RAM with different capacities and speeds. Depending on the size of your motherboard, you may have fewer or more RAM slots. These are the slots where the RAM modules are installed. The standard RAM used in desktop computers is called DIMM, which stands for Dual Inline Memory Module. It's called dual inline because both sides of the RAM have these gold contact pins. As you can see, DIMMs are fairly large, which makes them unsuitable for laptops or mobile devices. To solve that, a smaller version was created called SODIMM, which stands for Small Outline Dual Inline Memory Module. These are used in laptops and other compact devices. On the RAM module, you'll see small black chips. These are the actual memory chips. They are dynamic random access memory, or DRAM. It's called dynamic because the data needs to be constantly refreshed, otherwise it's lost. You can think of it like a forgetful brain. If information isn't repeated, it disappears. The type of memory we commonly use today is SDRAM, which stands for Synchronous Dynamic Random Access Memory. Why is it called synchronous? Because its clock speed is synchronized with the CPU's clock. This allows the CPU to access data more efficiently. RAM is also categorized by how much data it can transfer per clock cycle. Originally, we had SDR, Single Data Rate Memory, which transferred one piece of data per clock cycle. Later came DDR, Double Data Rate, which transferred two pieces of data per clock cycles. As technology advanced, newer and faster versions of DDR were introduced. We got DDR2, DDR3, DDR4, and DDR5. Each new generation brought higher speeds and better performance than the previous one. One thing to keep in mind when buying a memory, check which memory your motherboard supports, because again, just like CPUs, different motherboards support different RAMs. That was the internal components part 1. Stay tuned for the second one. Thank you.